Good day, students. Today we'll be working a question from the May-June 2013 past paper, Section C, number 10b. So the question asks us, given a capacitance of 10 microfarads and a resistance of 5 ohms connected in series with a supply of 500 volts with a frequency of 50 Hz, draw the circuit diagram and draw the equivalent phasor diagram. So, as usual, we write down the things that we are given. So we were told that the capacitance is 10 microfarads, which is the same as 10 by 10 to the minus 6, because micro is 10 to the minus 6. Now the resistance is 5 ohms, the supply voltage 500 volts, and the frequency is 50 Hz. So we draw a circuit diagram with our supply of 500 volts, AC supply, capacitance of 10 by 10 to the minus 6 farads, which is the same thing as 10 to the minus 5 farads. So I just changed it in the diagram. And a resistance of 5 ohms. So this will be the circuit diagram because the capacitance and resistance are in series. Now to draw the phasor diagram, this is a useful relationship to remember, which is ICE, which is current leads voltage in a purely capacitive circuit. Now, the circuit that we have here is not purely capacitive. However, the current will still lead the voltage, but it will not be by 90 degrees unless it's a purely capacitive circuit. But for the purpose of this phasor diagram, we will use 90 degrees. So, to draw the phasor diagram, we know that the voltage will be as the reference point because the voltage has no phase difference between the current and the voltage in the circuit. The resistor voltage, I should say, which will be the voltage across the resistor in the circuit. So we use that as the reference voltage. So this will be straight to the origin. If you were thinking of this as an axis, then this will be at the origin along the x-axis. And we have the capacitive voltage, or the voltage across the capacitor, lagging the current by 90 degrees. Remember the relationship ICE, current leads voltage. Alright, so they ask us to calculate the capacitive reactance, and the formula for capacitive reactance is 1 over 2 pi Fc. So we have F and we have C. F was given as 50 Hz, and C, we know, is 10 to the minus 5 farads, which gives us a value, when calculated, of 318.31 ohms. So now that we know the capacitive reactance, or XC, we can calculate the impedance. Impedance, or Z, is equal to the square root of R squared plus XC squared. And we just calculated XC, and we know the value of R as 5 ohms. So putting these into the formula, we get a value of 318.35 ohms. Now, having the impedance, we can calculate the current in the circuit. And it's a series circuit, so we know that the same current will be flowing through both the capacitor and the resistor. So, from Ohm's law, we know that V is equal to I by R. So if we transpose that equation, we will get I is equal to V over R. However, because this is not just a purely resistive circuit, we use Z, the impedance. So I is equal to V over Z, where V will be the supply voltage Vs. So 500 over 318.35 will give us a current of 1.57 amps. Now, to calculate the power factor, we use a triangle which relates the impedance, the capacitive reactance, and the resistance. So we know that power factor is equal to cos theta, or cos phi, and where phi will be the angle within this triangle. So we know that cos theta is equal to adjacent over hypotenuse, or from the relationship SOHCAHTOA, cos theta will be equal to adjacent over hypotenuse. So using this relationship, we could find the adjacent, which will be r, and the hypotenuse, which will be z. So adjacent over hypotenuse will give us r over z. So cos theta is equal to 5 over 318.35 as we calculated above. And this will give us a power factor of 0.016.